Hello, algebra friends. This is our lesson on algebraic expressions. We're going to start with a little bit of vocabulary, and then we're going to talk about how we can simplify some algebraic expressions for the beginning of our Algebra 2 class. So, let me make sure I don't make ding-ding noises when I'm clicking pens. We're going to start with here some vocabulary. Now, in true Abruzzo form, we have a typo right away. This is supposed to say underline any constant terms. We're going to circle any variable terms, and we are going to then simplify the expression. So let's start with circling any variable terms. So when I look at my algebraic expression, any term that has a variable with it would be a variable term. And the reason we call those variable terms is because depending on what the variable represents, we're going to get a different value each time. So then they want us to underline any of our constant terms. Well, constant terms would by process of elimination, not have any variables, and they're going to constantly be the same value that they're provided at the beginning of the problem. So that 9 will always be a plus 9, and this one will always be a plus 1. So when we go to simplify everything, we have here, this is like a 1k, and we're adding to that a 10k, and that's how we're going to get an 11k. And then we're going to simplify the constant terms. 9 plus 1 is going to give us a positive 10. And that's the simplified expression. Now, if you wrote the 10 first, there's nothing wrong with that. There's just some silly rule in math where if you want it in what they call standard, like appropriate form, they put the variables first in decreasing exponential order. We'll talk more about that when we get to quadratics. All right, same idea here. We're going to be circling the variable terms. So here we have a 1n, and here we have a negative 4n. And we're going to underline the constant terms. So we have a plus 10 here, and I think that's a minus 3, but my pen got a, oh, no, see, good thing I checked. That's a plus 3. So now we're going to collect those like terms. So we're going to start with 1n plus a negative 4n. So you're combining these, meaning you're adding these together. So 1 plus negative 4 is a negative 3n. And then for our constant terms, I have a positive 10 and a positive 3. When you add those together, you get a positive 13. And that is the simplified expression for that algebraic expression. Again, order doesn't matter, but signage definitely does matter. If you put a positive 3n instead of a negative 3n or anything else, it would not be correct. All right, same instructions, new problems. So we're going to be circling our variable terms again. So on this problem, there's only that one variable term. And then we do have a positive 2 and a positive 4 as our constant terms. So those are the only things we're going to need to combine. So we have x, and then positive 2 and positive 4 added together would give us a positive 6. Man, I'm getting a little crazy with my ink. I need to rein it in. All right, variable terms here. We have a negative 4a and a negative 3a. And then for our constant terms, we've got a 1 and we've got a negative 5. Again, order doesn't matter, but variable terms technically should go first if you're going to be, the perfect math person. Negative 4a added to a negative 3a, which you could do that coefficient work on your calculator if you had to. Sometimes adding and subtracting negatives makes people make silly mistakes. So negative 4 plus negative 3 is a negative 7a. And then 1 plus negative 5 is a negative 4. And that is our simplified expression. So got some vocabulary under our belt now. I did throw another vocab term at you called the coefficient. Coefficients exist on any variable terms. There's always a coefficient. Like for example here on this x, there's always a number in front of it representing how many x's you're talking about, and we knew that was a 1x. We don't typically write the 1, but you can. It's not wrong. All right, same directions, more problems. Here we go. Circling the variable terms. There we go. And then we're going to underline our constant terms and simplify. So positive 9v plus positive 3v, adding these together gives us a 12v. And then 2 plus 4 is plus 6. All right. Booking now. Here we go. Variable term here. Remember that's a 1k. The coefficient on that is always a 1 when you don't see anything. And then here we have a negative 5k. And then this time there's only one constant term. So we're going to go ahead and collect our like terms here for our variable terms. I have 1k, and we're adding that to a negative 5k. So 1 plus negative 5 is negative 4k. And then there's only the one constant term, so I'm just going to drop it down into my answer, negative 4k plus 10. My K's are looking real weird. Sorry. Okay, these next few problems, maybe this property is, you're getting some math reminders in your brain going off right now. If you can remember what that property is called, that's awesome. If you can't, I'll tell you now. This is called the distribution property. So I'm going to write that here. Distribution. All right, and just to distribute, it's the opposite action of factoring, which we'll talk more about in the class later. It means that you're going to take this 6 and you're going to distribute it to each term. And this is a multiplication. Wow, I can't write. Okay. So 6 times k is what you're really doing there. So I'm going to write it out the really long way right now. And I'm only doing this very, very slowly for us right now because this is where a lot of like conceptual mistakes exist in kids' brains, and this is the time to fix them. So 6 times k, better known as 6k. And then 6 times 4, better known as 24. Now, ideally in Algebra 2, you'll go from here to here. You don't have to write this middle step, but, there is no shame in you writing that middle step. You are more than welcome to. So here, we're going to distribute this time. Careful, it's not just a 6, it's a -6. So again, I'm going to write this out the long way. It's -6 times 8. And then you also have a -6 times, I'm going to use parentheses here just to confuse everybody, I guess, times a -a. Here, I'll use them here as well. So when you think about what that's going to simplify to, well, -6 times 8 is -48. And then here, -6 times -a, well, 2 negatives multiplied together actually become a positive, so that becomes a positive 6a. Again, this is a good answer. Perfect math form would be 6a minus 48. But of course, I'm not going to really care at this point. I just want you to be able to simplify, in this case, distribute correctly. All right, same idea here. We're distributing, but now we have a variable that we are distributing. So if you were with me in class yesterday, the previous day, you probably, we did some warm-up with this kind of work. So 2m times 5m. Again, I'm going to write this out the long way, but I'm kind of hoping we don't have to do this in the future. And then that 2m is also going to get multiplied by a 1. Now, if you don't like the dots, a lot of kids don't like the dots because they could be anything. You can use parentheses like this. So 2m times 5m is going to be a 10 for a coefficient, 2 times 10. And then m times m, we're going to shorthand that using exponents and call it m squared. And then 2m times 1, that's not very exciting because 2 times 1 is still a 2. So this just becomes a 2m. Now this algebraic expression, the resulting simplification, we have 2 terms here, but you'll notice that first term has an m squared. We're going to learn more about this later, but this is called a quadratic expression. All right, same idea here. You got the -3k times k. I'm going to write that out the long way for now. And then we got another -3k, this time times the -2. Oh my gosh, I'm going to have to learn how to write before school starts. All right, here goes. -3k times k. The coefficient is still a -3. K times k gets shorthanded to k squared. And then here we have double negatives, so negative times a negative is now going to be a positive term. The coefficient is a 6, right? 3 times 2 is a 6. And then for the variable, there's only just a k there. I don't know what happened to my writing, guys. Apologies. It's not getting any better. All right. I think we're ready to move on. This time, I'm going to try to distribute and not show that intermediate step of like what times what. Let's see if we can do that. We're going to do that part in our head. So 8 times 9n, you got to multiply the 8 and 9 and get a 72n. And then 8 times -10 is a -80. But don't forget there's this extra little term over here, this plus 4n. So this would not be a good answer if your teacher asks you to simplify, which math always wants us to simplify. You've got a 72n, a variable term there, and then you've got the same kind of variable term here, a 4n. So these are going to be collected like terms, 72n plus 4n, better known as 76n. And then that constant is the only constant in the problem, so I'm just going to say -80, and that's my final answer. All right. Now careful on this next one. The 7v squared is its own variable term off to the side. After that, we have a -v, or you can say subtract v, but then we have a product. We have a multiplication here. So when I go to distribute this, I'm not going to distribute just the v. I'm actually going to distribute the negative v. So think of it as negative 1v. All right, so the 7v squared from the beginning just kind of drops down. And then when you have negative 1v times 1v, that would be a negative 1v squared. Now, if you wrote the 1 in front of v squared, you're totally fine. It's not wrong. Negative v times 7 is negative 7v. Sometimes I get kids who write negative v7 and they are ashamed. They feel like they've done it wrong. It's actually not wrong at all. It's just weird. We don't usually do that. All right, but what we do have to do is simplify. So 7v squared minus 1v squared, you can also think of it as 7v squared plus a negative 1v squared. Either way, it's going to give you a 6v squared. And then this extra variable term, but notice it's a different kind of variable term. This is a v squared. These are like terms. This is just a v term. So we don't consider those to be like terms anymore, and we no longer can add or subtract them together. That's the phrase you probably saw a lot of in Algebra 1. They would say, collect your like terms. That's what we're doing. All right. More of the same. Here we got a 3 to distribute. That 1 that's at the beginning of the problem is not involved in the distribution. So 3 times negative 1x is a negative 3x. And then 3 times a negative 8 is going to be a negative 24. So as I look through this problem and try to collect my like terms, I notice this is the only variable term in the whole problem. But we do have, I'll use red, why not? I do have some constant terms that I need to collect. Those are the same kind of terms. So we have a 1, and we're adding to that a negative 24. So 1 plus negative 24, if you can do the 1 minus 24 in your head, that's cool. A lot of kids like to always think of it as an adding problem, though. Whoops, I'm about to put a variable on it, and there's no variable on constants. So negative 23, and then there's still that minus 3x, and I'm just going to drop down. If you rewrote it in the proper order, that would just be very special and mathy of you. I like it. All right, this next one, I'm going to distribute, careful, a negative 3x. So negative 3x times another x is going to be a negative 3 coefficient, and then x times x will get shorthanded to x squared. And then negative 3x times 4 is negative 3 times 4, so negative 12, and then an x. But don't forget, there's still that extra term of negative 7x squared. So when I go through and I notice, okay, these are all variable terms, but only like terms can add and subtract together. So when I go to combine my like terms, I notice right here I have negative 3x squared, and to that I'm combining it with a negative 7x squared. So negative 3 plus negative 7 is a negative 10x squared. And then this minus 12x, which is a different kind of term, I'm just going to drop it down. That is in what we call standard form for algebra. The x squared terms would come before the x to the first terms. But again, order doesn't really matter. I'm not going to be that picky right now. All right, who's up for a little fun here? This is the ultimate challenge. We got double distribution and collecting like terms. Let's get to it. All right, so this first problem, we're distributing a 5 into that first parenthesis set. And then afterwards, you're going to distribute this positive 7 into the second parenthesis set. So 5 times 10, better known as 50. And then 5 times 6v is 30v. And then positive 7 times 1 is positive 7. And positive 7 times positive 3v is positive 21v. And that would be awesome if we're done, but we're not. Take a closer look. We do have some like terms. We have some v terms. They have v to the first power on both of these. So those are like 30v plus 21v, better known as 51v. And then we have some constant terms to collect as well. I have oh, I'm doing weird notation. That's okay. All right, 50 plus 7 is plus 57. And as you can tell from my handwriting, it's not getting any better. I'm so sorry. Oh, that's what I should do over the summers. Write a little bit more. I guess I never did any writing. My hand is already tired. All right, next problem. Again, we have some double distribution. In this first parenthesis set, we're going to distribute in a positive 3. And then in the second parenthesis set, we're going to distribute in a positive 7b. So 3 times negative 6 times b would be a negative 18b. And then 3 times 10 is a plus 30. And then positive 7b times 1b is positive 7b squared. Ooh, that's ugly. And then 7b times negative 8 would be a negative 56. Oh no, I'm out of room b. Ugh, that 6 looks like a b. Oh, that's terrible. Okay, anywho, we got to be real careful here because we're going to be collecting our like terms. But you might notice this is a 7b squared, and as I look through the problem, there's no other b squared terms. So this 7b squared is like its own little term. There's nobody alike to him, and he's all by himself, and that's okay. All right, after that, I'm going to collect the b's, the b to the first powers. So I've got a negative 18b, and then a negative 56b. Oh no, it's the summer, and my brain hasn't turned on yet. Okay, so negative 18 plus negative 56. It's kind of like adding a negative 20 to it. So let's see, negative 74 is what that comes out to. I hope. All right, and then finally, I'm looking for constants. You know what, guys? There's just that one constant right there. So plus 30. And that is our simplified expression. Okay, I think we got a couple more, and then we're going to be done after that. So we're distributing the negative, and it's like a negative 1 that you're distributing. So if you want to think of it like a negative 1, you're multiplying a negative 1 into the first parenthesis set, and then an 8n into the second parenthesis set. So negative 1 times 5n is a negative 5n, and then a negative 1 times a 3 is a minus 3. And then positive 8n times 1 is a plus or positive 8n. And positive 8n times positive 2n is a positive. And then 16 is our new coefficient. N times n, we're going to shorthand that to n squared. And of course we're not done. I do see just this is the only n squared term, the only quadratic term, so I'm going to write that down. However, we've got some what we're going to call linear terms here to collect. Negative 5n plus 8n is a plus 3n. And then negative 3 is the only constant in the problem, so he's just going to kind of trail on the back end there. Again, order doesn't really matter, but very neurotic mathematicians like to put it in standard form order. Like me sometimes, not really. All right, k. 1k, remember that's like a 1k that you're going to distribute into here. And then a 4 that we're going to distribute into here. So 1k times 5k would be a 5 for a new coefficient, and then k times k is shorthanded to k squared. 1k times 1 is plus 1k. I'm just going to write k. If you wrote a 1k, there's nothing wrong with that. And then positive 4 times positive 9 is a positive 36. And then positive 4 times a negative 6k is a negative 24. Oops, squeeze in the k. There we go, k. So as I look through my terms, trying to collect my like terms, again, this is the only quadratic term in the problem. So I'm just going to write down 5k squared. And apparently I'm going to do it as ugly as I possibly can. Now I'm going to go collect these linear terms that are just k's. So remember, this is like a 1k, and then we're adding to that a negative 24k. So 1 plus negative 24 is negative 23. If you don't believe me, use your calculator. I'm telling you, there's no shame in using the calculator to double check, guys. Even like astronauts and people who help astronauts land space shuttles, they check their work on their calculator too, because if they don't, people die. This is not that severe, but you know, still check your work. All right, especially when you're trying to shake off that summer fog like I am. So that's our first lesson for 1.3. We're just simplifying algebraic expressions. In the follow-up lesson to this, 1.3 day 2, we're going to be basically evaluating algebraic expressions, which means we're going to get numerical answers in most cases where I'm giving you values to substitute in for the variable. All right, good luck.